I'll go ahead and start by introducing myself. I'm Jonathan Arenberg. I am currently the Chief Engineer for Space Science Missions at Northrop Grumman in Southern California. And these missions include the James Webb Space Telescope, which I'll tell you a little bit about, and some of our work on future missions. So I've been asked to describe what I do on a daily basis. That depends on the mission and the problems, challenges that we face in any given time. So typically on James Webb, my typical day, or what I would do all day, would be to work on certain challenges of the design, the effects of ice or contamination, or working a certain thorny issue with regard to ground support equipment, test planning, test execution, basically any kind of problem that doesn't get solved at a lower level. And my role there was chief engineer. So the types of issues that would come to my desk would depend on the phase of the program, or the need for some of my colleagues to recruit other disciplines. And so basically I get the interdisciplinary hard problems, which I really enjoy working on. For the new missions, so these are the decadal studies. I'm supporting the academic science, technology, and development teams. Also working on some of our own internal ideas and technology proposals. So we're not only working on assisting other folks to make their missions a success, but trying to create other missions and concepts to push the field forward. So my particular academic path is both in physics and in engineering. So I had originally planned to go to college, get my bachelor's and graduate degrees in engineering, and go off. Bachelor's and graduate degrees in physics, and then pursue a mainly academic path. In my junior year as an undergraduate, I got the opportunity to get a summer job as an engineer. And at that point, in the early 80s, the minimum wage was about $2 an hour, and I was going to get about $9 or $9.50 an hour. And I could basically make all the money I needed for school in 10 weeks and not have to work all year. So that's what originally attracted me to the internship. And what I found out was that I really enjoyed the team aspect and the building part of engineering. And as a result, I moved some of my graduate school applications from physics departments to engineering schools, got into both kinds of graduate institutions, and then made a decision late in my senior year to become an engineer. And it's a decision I don't regret. And between the science background and the engineering, I kind of sit on this cusp between the two. I can flip back and forth depending on what's needed. So the best analogy from biology is sort of that clownfish that can switch into whatever the species needs in terms of a gender. So I basically got to the position I'm in by a couple of paths. Number one, obviously, the academic preparation, the curiosity to solve problems, particularly new problems, and the fact that I also spent the first 8.5 years of my career working on the Chandra X-ray Observatory. It was called AXAF when I worked on it, and I got a reputation for hold on, the computer wants to reboot. I'm gonna make it not do that. Pardon me. I got a reputation for being able to challenge and solve the problems that others couldn't or didn't want to deal with. And so I rather like that. I found out that I don't mind being told what needs to be done. What I don't personally like is being told how to do it. So I found a combination, a position that combines a lot of my personal attributes, my personality, my academic background, and then basically worked on it to the let me start over. Found a position or set of positions and a field in which my personality, my academic background played strongly to my advantage. So on the 10.5 years for the Webb mission, I started out by essentially being hired to run a technology program and test program that was in a little bit of trouble, and we managed to successfully complete that early technology development program, which was to demonstrate the performance of the backplane, which is key to our telescope performance. Brought that in, and while we were running that test, I was asked if I would be applying to the open position for Deputy Systems Engineer and Design Lead. And I really hadn't seen that ad in our sort of internal yellow pages. And then I was thinking about it, and then the phone rang, and it was the gentleman I'd be working for, who I had not yet met, and he said, "Gee, I'm very excited that you're going to apply. I've heard about you," and so on. And at that point, I took the hint and applied, and got the job as the design integration or the design lead for the system, and the deputy systems engineer. And then a few years later, I became the systems engineering manager, and then finally chief engineer when our program manager realized that leading the systems team was part business and a lot technical, and moved me to the technical only job of chief engineer that I've had for 4 or 5 years now. So basically, I'm in a job that is highly suited to my personality. It's very wide open. I work very well in an unstructured environment, and I have a lot of fun doing what I do. So a typical day, really there is no such thing. They're all quite different. It really depends on what's happening, since a lot of my current job involves interfacing with scientists and other engineers from the NASA centers, making new scientific friends to develop new missions, and also to talk to visiting dignitaries. So there's also a fair amount of sales involved. I'm not only a dedicated scientist and engineer, but do enjoy a lot of other hobbies, reading, writing technical papers. My own resume reads a lot more like an academic than an industrial scientist and engineer. My wife and I enjoy cooking, including everything from bread making to mixing some nice drinks, which we got to do over the weekend. You've already seen one of my cats. My wife and I have 3, and I'm also quite civically active. Previously running two small charities, and I'm a 25-year veteran of judging at the California State Science Fair, where a colleague of mine and I also give seminars to teach how to do better science to the students. And then my other main hobby, I guess you could call it that, is I'm a retired competitive weightlifter, having won the national championships, the United States national championships, in the mid-90s, and went on to be on the world championship team in 95 and 96, but I still go to the gym and train. I just don't compete anymore. So I'm quite busy, both technically and outside the technical arena. My best bench press at 120, I weighed 122 pounds, and it was 319 pounds, so that's what, 142 and a half kilos, I think. So it's pretty good. It's close to 2.5 times, a little bit more than 2.5 times my body weight. So that was, yeah, it's a lot. But I snuck up on it slowly, and in fact, I actually started lifting because of my office mate when I was working in the physics department at UCLA. I had run in high school, and I could bench press the telescope. Well, I can pick up heavy parts of it, but we don't do that. That's why we have cranes. But yes, I have been called over to lift up non-flight hardware that required some moving. So that also makes me occasionally popular, particularly with the secretaries when we have to move boxes of paper around. So let's see. Sure, I'd be happy. The question is, can I give a bit of background on the James Webb Space Telescope and what it can do that Hubble can't? The Webb Telescope has 4 main science missions. The first is to see the first stars and galaxies, the so-called first light epoch. Because we can image at high redshift, we can also take images and spectra at lesser redshifts and understand the assembly of galaxies. And then within the galaxy, to study the formation of stars, planets, and interrogate, observe those extrasolar planets, particularly in transit, but some with direct imaging to understand their atmospheres and perhaps the conditions that will allow for life to develop. So the driving set of requirements really are those first light requirements. And Webb can see beyond Hubble basically because it's designed to do so. It's about 7 times the collecting area, and unlike Hubble, which operates in the visible and the very near infrared, the Webb telescope is predominantly an infrared instrument. So it is cold and large. Its orbit is a million miles from the Earth, taking it out of the neighborhood of the Earth. Its heat, its blockage of the sky, and behind the very large sun shield, we can hide the sun, the Earth, and the moon, giving the Webb telescope a permanently dark, cool place to carry out its mission. So even though we are 7 times the collecting area, a little bit over 7 times the collecting area, of Hubble, we weigh about 55 or 60% of Hubble's mass. And that's one of the key enabling technologies. One of the major differences is we're about 15 times more efficient in terms of mass, taking mass to orbit. So that's the highlights. And I have been working on star shades. In fact, I was one of the co-inventors of the revised star shade concept in the early 2000s. Great. I look forward to more questions. The star shades, for those that are not familiar with them, are a so-called binary optic. That is, they either completely stop the light. Let's see, is there any scope at all service in case of an issue? I think you were talking about the Webb telescope. We have been asked by our customer to put on docking fiducials. The prime Webb mission does not have an explicit requirement to be serviced, but after some study, both at our shop and primarily at the Goddard Space Flight Center, where they have a group looking at robotic servicing, there aren't any impediments, certainly, to refueling a Webb should a robotic refueling craft exist. That is, there's a place to grapple the spacecraft, primarily the launch vehicle interface ring, and the fill and drain valves are accessible, so it is entirely possible to refuel in space. It's just not part of the baseline plan. I should hasten to emphasize that there have been other missions done by other agencies in the government that have transferred fuel. NASA has done it on the space station robotically, and so has DARPA. So the primary path to quality is to do rigorous design and testing on the ground and make sure that there aren't problems for the launch, not rely on servicing to fix it. So Adita, I hope that answers your question. Yes, the option's open, and certainly servicing for the for future missions is a much higher and more explicit priority. So Sanjoy was asking, how would my perspective change if the instrument discovered signatures of life on an exoplanet? Well, two ways. Number one, I'd be incredibly gratified that I contributed to such a momentous discovery, and so personally, I'd be very, very proud. I think scientifically, I'd kind of nod my head and say, yes, I do expect to find life elsewhere. Life on this planet is amazingly diverse. The atoms and molecules that make us up are quite ubiquitous. As we learn more and more about, I'll call it chemistry of the cosmos, it does look like precursors for life sort of abound, and it seems highly likely. The next question is, how efficient would a single star shade be in terms of the number of targets imaged? How difficult would it be to employ multiple star shades? So the challenge for any starshade only mission is to do both the detection, the initial detection identification of extrasolar planets, and then do their characterization, which would include, at least in my head, both orbit determination and spectral characterization. Spectral characterization, given the optics, is pretty straightforward, and in fact, Starshade is uniquely capable of doing that in an efficient fashion. The detection and orbit determination requires multiple visits, and that's where will be less efficient. We have studied multiple Starshade missions. We did that some time ago and published several SPIE papers and AIAA papers on how you would coordinate multiple Starshade missions. It does increase the efficiency because you can be observing with one Starshade and positioning another. The scenarios that we studied involved one large and one small Starshade, so that you could have an efficient search with the small Starshade and follow it up with tighter inner working angle and greater contrast with the larger shade. So Warren asks a question, will Webb look for brown dwarfs? I think undoubtedly yes. That's really a question for the scientists and those that are selecting the proposals based on their scientific merit, but we can certainly look at them, these cooler stars. In fact, a lot of people are talking that that's the most likely place to find a habitable a planet. It may not necessarily be inhabited, but around these cooler stars, for a lot of reasons, that's an interesting place to look. Okay, so the next question is since Webb is going to be observing the near IR, is there a Spitzer-like cold and warm mission phase, or will we have similar sensitivity throughout its accepted life? Spitzer was cold because it was actively cooled. The telescope itself was placed inside a Dewar, and when the cryogen was expended, the telescope, of course, warmed up. The Webb telescope is a passive architecture. So once the sun shield is deployed and makes the shadow, we have no expendables required to get down temperature. The actively cooled MIRI instrument is cooled with a closed loop refrigerator called the cryo cooler. There's no expendables there, and the only expendable is fuel. So we won't have a cold and warm mission phase like Spitzer, but we will be cold. Once we get cold, we will stay cold throughout the mission. Sanjoy was asking, what did powerlifting teach me that I didn't get in my academics, and how has that helped in my career? It's taught me a lot of things. Number one, that I really can do a lot of things by working hard for a dream. I had no expectations that I would win, and yet to defend a national championship did teach me to deal and enjoy with working with a wide variety of people. The ability to meet and work and enjoy with a lot of people is a real advantage, because as I frequently will say, engineering and science is a team sport, and so being able to be a good member of a team, knowing when to lead, when to follow, I think is a powerful career lesson. So Nick was asking, what is my favorite space-related mission of the last decade? I'm going to go with the one that I'm most closely associated with, and that is the Chandra X-ray mission. I spent the first 8.5 years working on that great observatory, the sister of Hubble, Spitzer, and the Compton Gamma Ray Observatory. It's still flying, still producing amazing, groundbreaking science. And as soon as Webb joins it, then I will have two favorites. But that one's kind of a very, very personal answer. I still see a lot of the customers, the end users, the astronomers that use the Chandra Observatory on a daily basis. And I'm always gratified to see that it's still producing breathtaking science as it nears its 18th birthday. Let's see, so the next question from Shaylin, hope I pronounced your name right, is where do I see the field headed in the next few decades? I see the field heading to, unfortunately, less frequent, but even larger and more breathtaking systems. The systems that we're studying vary from telescopes that are 4 to 5 times the size of the planned Webb telescope, the nascent Webb telescope, I should say. X-ray telescopes that have 50 times the collecting area of Chandra, yet the same resolution. Far infrared missions that are the size of Webb or larger. So I see the field continuing. The space science field is been very successful in producing these, not only these leapfrogging, breathtaking flagship missions, but a number of extremely innovative smaller missions. NuSTAR, the high energy X-ray mission, SWIFT. Kepler is an example of that smaller class of mission that's doing of breathtaking science. I'm hoping that we can leverage not only new manufacturing technologies, but new ways to look at solving the fundamental engineering problems and get the launch rate back up. So, I'm in the middle part of my career, so I hope to be around to be part of that next revolution of doing what I will call a higher cadence of these leapfrog missions. But I mean, if you'll pardon the pun, the sky's the limit. The types of missions are really exciting, and part of how I see my role is making them happen faster and more affordably. Sanjoy was asking how have I benefited from mentors in my career, and how, and I think the answer is absolutely yes. Starting from my very first mentor and teacher, my parents, who encouraged me to find out what I liked and follow that, to some high school teachers, both my biology and my physics teachers in high school when I was in 10th grade, which is when high school started for me in Santa Monica in the 70s. I did a DNA transfer experiment, which was quite exciting in test tubes. And I was on my way to becoming a microbiologist because I had really enjoyed it. And then my physics teacher got hold of me and showed me the benefits of the mathematical sciences. I had a lot of really good professors, professional mentors. I mean, in fact, my very first supervisor as an intern was still doing me a good turn, and in fact wrote a letter of recommendation to SPIE that supported my election to fellow. And so now I really feel strongly that it's my turn to pay back. So I think mentorship is an extremely important part of any professional development, but especially so in the sciences. So the next question is with regard to exoplanet atmospheres. Will JWST or the next generation of ground-based large telescopes determine the abundances of biogenic gas? Basically, we have the opportunity to take spectra of transiting planets and do a great job. Spitzer and Hubble have already started that work. We will have, on the Webb telescope, that's what I mean, Webb will have greater collecting area and be able to do a good job for some of these gases, but the direct design of those kinds of systems is really the focus of these next generation so-called LUVOIRs or the HabEx type missions that are currently under study. I believe the ground-based telescopes are a little impaired due to the presence of gases in our own atmosphere, which makes detection a bit difficult. Let's see. Jacob asked the question, do you have any suggestions for how astrobiologists who spend most of their time in the lab working with theory could become more directly involved with space missions? Yes, just do it. Go out, it's as simple as making friends and saying yes to work. Go sign up for these volunteer committees. Go show up at the Astronomical Society and the Department of, Division of Planetary Sciences and volunteer for committees and make yourself valuable. I think people offering to do worthwhile works become valued members of the team, and I think that's a good paradigm for all of us. If you see an area you want to get involved in, pick up the phone, call somebody, send an email. It's amazing how well that works. Warren asks, are there ground-based telescopes on a path to replace some space-based telescope capabilities? I think some of the large ground-based telescopes will overlap in terms of capability with space-based, but the ground-based telescopes always face the fact that you have the pesky atmosphere that corrupts the seeing a bit, absorbs some of the precious photons that we want. On the other hand, ground-based telescopes can easily evolve, extend, far easier to replace instruments. I personally see them as a complement to each other and not in fundamental competition. So, speaking as an academic, what is my opinion on the EU's recently proposed open access scientific publication? I'm a real proponent of easy exchange of ideas. I'm always a little frustrated when I want to go find a journal and find out that I have to pay or be a member of a library that has access. So I don't know all of the details of the EU's proposal, but I do know, in fact, I took a survey over the weekend about open access, and I do know that that's a big trend in publishing. We here in the States, in fact, as part of the establishing law for NASA, do share all of the scientific data from our missions in open archives, and so I'm a major proponent of sharing the scientific wealth and getting as many good brains wherever they may be to work on the challenging problems that we all find of interest. Let's see, can I describe a frustration I encountered during the build of the Webb and what steps you took to overcome it? Sure. Like I said, I get these kind of weird, odd problems landing on my desk, the challenges that kind of fall between the cracks, and I'd have to say that if I was frustrated at any real time, it was with my own ability to communicate a complicated problem to management in order to get an answer to allow us to proceed. So I've gotten a lot better at it, and so the initial frustration was the inability to communicate, not necessarily a frustration that people didn't want to do the right thing. Everybody on the program, from managers on down to the lowest technicians, are striving for mission success. So the frustration I would have would be with my personal ability to describe a problem, and then occasionally that it would take me so long to come to a solution, because once we found the problems in retrospect, of course, the path to solution is always very straightforward and very linear. Webb does not, so Warren asked the question, does Webb have a baseline observing strategy? Certainly in the early years, a fair amount of the time is dedicated to the folks that helped build it, with a plurality of time from guest observers made by proposals. But basically, this is going to be driven by proposals from scientists reviewed for the highest scientific return. So, this is like all these major observatories. The observing strategies and goals are mainly, at least in my head, a device to drive the design in the desired direction to produce the most capable scientific instrument. And then once released into the wild, if you will, it's really driven by the serendipity of discovery and what becomes a hot and interesting topic when the design studies started for Webb in the late 90s. The first exoplanet discovery was only about 18 or 20 months old. It really wasn't part of the primary mission, but as we evolve, I'm sure that exoplanets will play a large role, and I'm sure emerging science will also guide the use of the observatory. So Jay Chaddock asks, as a current high school junior and hopefully future physics astronomy major, what would I recommend in order to hopefully succeed in a career in sciences? So I would certainly obviously recommend you study hard in the sciences, but success in the science is not limited to just the ability to sit down and solve physics and chemistry and math problems. It's also, like I said, a lot about communication and teamwork. So I would also encourage you to study a lot of other things. I read a lot. I still read about a book a week for recreation, primarily history and biography. So sometimes the people I read the biography of were great leaders, military, political, scientific. I get inspiration for how to be a better technical leader from there. But I also work on my soft skills, the team sports, the other ways to connect with people. Typically, a lot of our challenging problems, both on Webb and on Chandra, frequently were matters of communication. So being able to communicate, making people feel comfortable to describe a problem even when they may not be the expert and they're worried about being teased for not being the smartest kid in the room, and making people feel comfortable and getting the best out of everybody is certainly a good skill, and you won't learn that in your typical physics, engineering, chemistry, or math class. So I would certainly recommend, obviously, study hard in the technical areas, but work on developing your whole persona, because science, and certainly engineering, is not a solitary profession. So, Let's see. I mean, one of my my favorites in history was the gentleman who my elementary school was named after, and that was Ben Franklin, who who's known for many things. You know, businessman, diplomat, uh, swimmer, but he was first and foremost a scientist. You know, he was a member of the Royal Society. He was very popular uh, in France because of the invention of the lightning rod, and he used all of that to help birth the nation. In addition to being the only man to sign all four foundational documents of the Republic. You know, other folks. You know, my favorite Renaissance figure, Galileo, who in addition to you know, being a scientific titan, also had a very snappy literary style. And you're welcome, Jay. Uh, uh, that resonates to this day. So it underscores what I just told Jay. If you go back and read the Starry Messenger, Sidereus Nuncius, the very small pamphlet that Galileo published to spread his discoveries, you'll see, number one, it's written in a very easy to understand style. Even today, even if you know what the information he's trying to convey, but just the idea of that kind of mass communication is particularly inspiring to me. Sure. Oh, let's see. So the question is, how have I handled lows in my career path, if any? The answer is yes. Life always hands you uh, low points. Uh, I had a challenge early in my career. I did not handle it very well, to be quite honest. I was impatient, uh, but I was young and not experienced. Right? The definition of experience is recognizing a mistake when you're about to make it again. Uh, so typically, and more lately, if there were bumps in the road or lows, uh, kept my eyes on the big picture. What was I trying to do? Was I on that path? And then also, you know, dealing with it in a very business-like, unemotional manner. I'll I'll give you an example from the distant path, so no one will be injured by the telling of this story. I was working a lot of extra hours to help prepare for the preliminary design review for the what was then called the AXAF, now called the Chandra Telescope. And I was writing memo after memo and doing analysis after analysis to get ready for the preliminary design review. And I got what I considered to be an average or a middling review and raise that year after doing all of this work. And so I just very calmly explained, you know, to my functional manager that, hey, I had done all of this. You were told that, and it seemed like it wasn't valuable. And I said, you know, do you want me to stop? And so I was not angry. I just dealt with it very matter of factly, and it worked out to the best. Other times you'll have other lows where you submit what you think is a brilliant proposal and it doesn't get accepted. Sometimes you just have to dust it off. I think I've learned some of that from certainly from lifting. I had a lot of success, but I didn't win everything every time. And sometimes you're just going to lose. Like the saying goes, sometimes the dragon wins. You just have to dust yourself off and keep your eyes on where you want to go and just keep on going. The next question is from Warren. Will Webb be able to detect black holes size range recently discovered using gravitational wave observatories? The Webb, I'm assuming, would be able to detect or be able to look in the direction. I think the real issue is cueing and timing. The the gravitational wave event was detected and recognized, but it took days and weeks to confirm, and by then, whatever optical or infrared signal would have been extinguished, most likely, from that merger. So I think the answer is in theory, we could see it if we were looking in the right direction. I think in practice, if we were looking in exactly the right direction, it would be an extremely rare event. Sanjay is asking, do you think there's room for closer collaboration between large aerospace corporations like my employer, Northrop Grumman, and academia and nonprofits? In a word, yes. We certainly do a fair amount of outreach, and we're trying to increase our collaborations with scientific and engineering entities of all kinds to sort of forge a renewed new look at the way we do business, both in the scientific and the engineering fields. So I'm open to any new ideas, and always willing to talk to people about good ideas for solving challenging and interesting problems. Sure. So the question is, do I have any words of wisdom for aspiring scientists and engineers? Thank you. I was going to throw that in. Could even throw in mathematicians. I'm a child of the space age. I found my path fairly early in life, and looking back on it, I enjoy what I do. I'm still propelled to work late into the night because I really like what I do. So, if you think you enjoy science, go ahead and explore it academically, and then follow that dream. If your dream is elsewhere, like my brother, who's a professional actor, you can likewise be very happy. So, if you're aspiring to be a scientist, be a scientist. Don't let anything stand in your way. Work hard, set your eyes on your goals, and just go. I think those are good words for almost any profession. This is one where hard work and dedication gets rewarded with all kinds of intangible benefits. The ability to contribute to these fantastic discoveries and truly advance mankind is almost beyond my vocabulary to express. So, if nothing else, I'm an example of a middle-aged guy who's been doing this now for 30 plus years. I still get out of bed on Monday morning at 5 o'clock, eager to go into the office and make some progress. I didn't do it yesterday because it was a holiday, but during the work week, of course, and even on the weekends, I work a lot. I enjoy it. So basically, find something you like. To do that, you really have to understand yourself. So try lots of different things. Try the biologies, try the engineerings, try the pure science, try working academics, try industry. Once you find your niche, you're set. I guess those are my aspiring words. Hopefully it's inspiring as well as aspiring. Great. Let's see. I want to thank everybody for the great questions and for the interest, both in science, engineering, and outreach. And I want to thank Dr. Sohm very much for the invitation to come join you today and address you and spend the last hour from you. And for those of you that got to see Orion in the beginning, he sends his regards, but he's he's moved off to a sunnier place to take a nap. Thank you all. And if you have any questions, my name is easy enough to Google. Feel free to ask me or ask Dr. Slum, and he'll get you in contact with me. So don't hesitate. Okay, I'm gonna go log off here, and I will save the file, and hopefully everything works great. So once again, this was a lot of fun. I hope to do it again soon. And for all the students, keep your eyes on the stars. You'll be amazed where you end up. Thanks very much.